the different means by which the leaf spring can be attached to the chassis during the suspension system, during the design of the suspension system. So I will write down the front end suspension. And so this is basically the types of leaf spring suspension. So there are different ways by which the leaf spring can be used in the suspension system. The first one is front suspension installation. Okay, so what it says, the front suspension installation. Basically, it talks about how you are going to attach the leaf spring to the body of the vehicle. So in front suspension installation with shackle at the front end and fixed at the rear end. Okay, so what is this method? Shackle at front end of the spring. Here the meaning of front is basically towards the driver's side. Okay, shackle is swinging support that allows variation in spring. This is shackle is basically swinging support that allows variation in spring length. So that allows variation in spring length as it compressed. That means जैसे भी spring compressed होगा, so जो भी variation है that can be accommodated. This design is almost obsolete. Okay, so it is almost obsolete design, but we should know it design, and is limited to trucks having front axle loading up to 4.5. Obsolete. It is used in trucks having front axle loading, up to 4500 kg. That means up to 4.5 tons. In this design, the steering gear at the rear of the front wheel. Okay, whatever. So I will draw the sketch how it looks like. So this is basically the shackle, which is usually of the hexagonal shape. So have this. Then this can swivel. This is attached to the vehicle body. This is going to be the part of the chassis. The other end is almost here, which is going to be the fixed end. This is the other end. This is called as the fixed eye, and this is the chassis frame where this particular bracket is welded. Now I will draw the spring with a different color so that you will understand that this is how the suspension system it works with this kind of spring. So this is the full length leaf. Then these are the graduated lives this is the connection. So this shackle can swivel about this. So this is one type of arrangement. So is this clear, sir? Anybody is having, this is the chassis frame. This part is the shackle, the complete assembly, and this is the fixed eye. That means this cannot move. So this is the arrangement. This is how you can attach the spring. The second one is the second arrangement of attaching the spring to the lift spring to the vehicle body is shackle at rear and fixed at front. So this is shackle at rear and fixed at front. So this is another mode of attaching the spring to the vehicle body. Then you can have this kind of arrangement. So this is the fixed end and the shackle is at the rear. So you can have the spring attached this way. Sir, these sketches, they are important because whenever you define the suspension system, and in that case, if you are by chance working in the group related to the suspension system, then you should know what are different types of the ways. And whenever, again, one more thing, even if you are not working in any automobile industry, please try to understand that if you watch the vehicle, if you inspect the vehicle, then you may have such kind of arrangement which you can have a look at it. आप जिस भी व्हीकल पे अपने प्रैक्टिकल के लिए काम कर रहे हो, सो उसके लिए आप देखिए कि ये किस तरह का, whether it is using this type of suspension system or not. Frame, so fixed at front, so this is going to be shackle at the rear, so this can swivel. This is the shackle at rear end and this is the fixed eye. That means there cannot be any movement. Then you can have the front eye is fixed and containing a camshaft bracket. So I will just write down this. You can have the look for these things in the book. तो सर अभी ये तीसरा जो टाइप है, so in the third type, front eye is fixed. Front eye is fixed and a contacting cam type and a contacting cam type bracket is used with sleeper at rear end with sleeper at rear end. So please note that these kinds of design you can refer it from the book because there are so many types of design. The main important thing what I wanted to tell you is See, you can fix the rear end or you can fix the front end. Basically, what is going to happen? You have to keep the space for the expansion of the spring length. Okay, so this length, basically, this length has to be, this is the length which has to be flexible. That means if I'm applying load from the bottom side, if the load is applied from the bottom side, then the spring will get flat and that has to be accommodated. So this is the another design. Then the fourth one is the above design also used in conjunction with AEON rubber overloading. So the above configuration can be used with rubber stoppers. Just to give you an idea, I'm just drawing the sketch. Let us say that you fix the फ्रंट एंड वाला है, ये है सर आपका स्प्रिंग और ये है रियर एंड, ये फिक्स्ड वाला एंड है। ये सर आपने यहाँ ऐसा स्प्रिंग लगा दिया इसको, ये अबव वाला यानी 3 and 4 वाला कॉम्बिनेशन मैं आपको बता रहा हूँ। तो ये जो हो गया फ्रंट एंड आइज फिक्स्ड। ओके, चलो मान लो इसको, चलो इसको फिक्स्ड कर देते, फिक्स्ड एंड इट कैन swivel. Okay, so if this is the arrangement, if you are using for fixing of the lift spring to the vehicle, then you can have the stopper arrangement like this. These are the rubber stoppers which are fixed, so you can have this kind of arrangement. I'm just giving you an idea. In reality it may differ. Okay, so just इसका थोड़ा सा आइडिया समझ लो कि ये सर रबर स्टॉपर है, and let us say that this is, so whenever the spring moves upwards, so it restricts the movement. This portion restricts the excessive. Right. So these are basically rubber stoppers. So such kind of arrangement is also used in order, sorry, this is on longitudinal axis. Yeah, yes, this is on the longitudinal axis of the car, Prajwal. Okay, that means it is along the length. Vehicle ka, it is along the length side. This I am showing you the diagram, whatever question you have asked. So ये अगर vehicle है सर, मान लो ये आपका, if this is the vehicle, then I am showing internal structure. It is, this is the chassis frame. Okay, ये यहाँ पे ऐसा रहेगा इसका, ये चैसी फ्रेम, तो इसको सर यहाँ अटैच रहेगा ये पोर्शन जो है ये, so this is along this particular axis, so this is longitudinal axis. It is not the transverse direction, but it is on the longitudinal axis of the vehicle. Okay, Prajwal. So these are the ways by which you can attach the sorry, leaf spring to the vehicle. Is this clear? Anybody is having any question? Generally, the main purpose is to isolate the vehicle frame from the road irregularities. So if this is clear to you, then we will move ahead. Shall we go ahead? सर आगे बढ़े क्या? ओके तो सर अभी हम लोग बात करेंगे डिजाइन ऑफ द लिफ स्प्रिंग का. So how what are the different formulas for designing of the leaf spring? So I will draw. This is basically we will be talking about the semi-elliptical leaf spring. So well, this is what is going to be required for calculation of the spring design. So we will do the design of semi-elliptical leaf spring. Just एक 2 मिनट के लिए. So design of semi-elliptical leaf spring. Now there are certain terms, certain formulas which we need. See, you may have the or you may learn the complete design process of the leaf spring in the machine design class. Here we are only restricted up to whatever the type of the springs which are used in the vehicle suspension system. So we will be specifically discussing semi-elliptical spring. So I will draw the figure of the semi-elliptical spring and will explain you the meaning of various terms in that and the method to calculate the different dimensions of the leaf spring. Okay, so let us say that this is basically the eye of the leaf spring. Here I will give you another thing. So this is now the thickness of the, if you see the leaf spring from the front side and if it is the semi-elliptical leaf spring, so I am drawing that particular view. Have you studied the design of the leaf spring? सर आपने पढ़ा है क्या? This is basically the central band. Let us say that this distance is Z. This the center distance I to I center distance. Let us say that this length is L. And there is one point here which will define the, this is the radius of curvature of the leaf spring. Let us say that now on this leaf spring, the load which is acting on it on the I side, let us say that this load is basically P. Okay, so P is maximum load on the spring then the reaction which is given at this particular I and this particular I, we are going to assume that it is going to be P by 2 due to symmetry. Okay. Now with this, we are going to write down certain things about the various parameters of the leaf spring, and then how to find out how this particular concept is applicable in the vehicle. That everything we are going to see. Let us say that P is maximum load on spring. Maximum load on spring. This may be due to vehicle weight. This may be due to the road reaction. So whatever may be the thing, but this is the ultimately load which is acting on the center portion where it is fitted to the axle. So L is the length of spring. T is the thickness of leaves. Thickness of leaf. Then B is the width of leaf. Small n is number of leaves. F is maximum stress. Delta is deflection of spring. Deflection of spring due to load. And R is radius of curvature of spring. Radius of curvature of sorry. So these are basically the parameters related to spring. Now we have to write down the expression for the calculation of these parameters. We are not going to derive any of the formula. So the maximum stress, let us say that F is given as F is equals to 3 times P into L divided by 2B T cube into N. So this is the formula. Everything is defined here. All the terms which are coming on the right hand side and left hand side, they are defined for you. Then delta, the deflection of the spring, is given as F L square divided by 4E into T. E is the Young's modulus of spring material. So Young's modulus of plate material, or you can say modulus of elasticity of the spring material, or you can say, or this delta is also given as 3PL cube divided by 8ENBT cube. So these are the formulae. Please note that these are applicable for for spring without any extra full length leaves. So this is the important assumptions or the constraint for using this formula. Please note that the full length leaf means whatever this particular full length leaf. Okay. This full length leaf is used in some spring. It may be more than one. here we are saying that it is 1. So if it is 1, then use this formula for the calculations. If it is more than 1, then you can have the formula which I will write down soon. Okay, for spring having more than one full length leaf. So the formula for the spring having more than one full length leaf is delta is equal to 3pl cube divided by 4 in bracket 2 plus r bracket complete ENBT cube, and this is also equal to L square F divided by 2 into 2 plus R bracket complete E into T. So this is the formula where small r is equal to number of extra, please note this formula, extra full length leaves divided by total number of leaves. This is equals to n dash divided by n. Okay. Example, if there are three full length leaves. साई कृष्णा इतना लेट क्यों ज्वाइन हुआ? full length leaves, then n dash becomes equal to 2. okay? तो सर ये चीज आपने याद रखना है, ये फॉर्मूले है कैलकुलेशन के लिए। अगर एक से ज्यादा आप फुल लेंथ लीफ यूज करते हैं तो इन दैट केस दिस इज गोइंग टू बी द फॉर्मूला टू बी यूज। नाउ रेडियस ऑफ कर्वेचर के लिए व्हाट इज द फॉर्मूला फॉर रेडियस ऑफ कर्वेचर? आर, so radius of curvature कैपिटल R, इसके लिए फॉर्मूला है सर R is equal to L square divided by 8Z. Z is the clearance when the spring is not loaded, plus Z by 2. Z by 2. This is also equal to L square divided by 8 times of delta plus delta by. Okay. And energy stored in, sorry, per unit volume, energy stored per unit volume is given by F square divided by 6 times modulus of elasticity E. नाउ अगर यहाँ मुझे लीफ निकालना है तो ये बी एंड टी रह गया था, तो मैं ये सर ये निकाल देता हूँ यहाँ। अगर ये सर लीफ है, ओके, सो आई एम जस्ट शोइंग इट इन शॉर्ट। ये अगर आपका लीफ है तो ये सर आपका इसका साइड व्यू है, ठीक है। तो ये जो डायमेंशन नीचे की डायमेंशन आपकी बी हो जाएगी और ये जो है ये थिकनेस टी है। That means if you see from this view, so if you see from this side, so this is the view. So basically this is the व्यू। अगर आप साइड से देखते हो तो उसके लिए ये आपकी फुल लेंथ हो गई और साइड वाला व्यू हो गया। सर किसी को कुछ इसमें डाउट है क्या? So sir, ये formulae, these are the formulas from the basics of the machine design. If you learn the design of the lift spring, then there are so many kinds of formulae which are given. So we will be only using this formula for calculation of the lift spring. So on the similar lines, can we write down the formula for calculation of the design of this coil spring? सर इसमें समझ में आया क्या? किसी को कुछ दिक्कत है, डाउट है? Shall we move ahead, or is there any issue as far as these formulas are concerned? Sir, please say yes, no, or you have any kind of doubt so that I can help you out in getting the clarification. सर बताइएगा, किसी को कुछ डाउट है क्या? ओके, चलो ठीक है। तो सर ये फॉर्मूले आपको याद रखने होंगे आपके प्रैक्टिकल में भी। अगर आप कोई व्हीकल यूज करते हो, सॉरी जिसका आपने स्टडी किया है उसमें अगर ये लिप स्प्रिंग दिया है तो आप कर सकते हो, तो वैसे तो कोई इशू नहीं है। तो सर अभी हम लोग फॉर्मूले लिखते हैं। Radius of curvature is after the deflection. No sir, it is not after deflection. After deflection the radius of curvature is going to increase. It is basically the design when you supply it with this particular load P, यानी जब तक के ये लोड P एक्ट होते रहेगा सर, ये P एक्ट होगा तो फुल डिफ्लेक्शन नहीं होगा, पार्शियल डिफ्लेक्शन होगा। अगर फुल डिफ्लेक्शन हो गया तो वो फ्लैट हो जाएगा। ठीक है, पहले सर अपन स्प्रिंग डिजाइन करते हैं, दैट मींस विथ कंसिडरेशन ऑफ लोडिंग द स्ट्रेसेस देखेंगे। उसके लिए हम लोग फिर रेडियस ऑफ कर्वेचर निकालेंगे, कितना क्लियरेंस रखना है उसके हिसाब से आपका रेडियस ऑफ कर्वेचर आएगा। दैट मींस आई विल से दैट दिस इज in the beginning radius of curvature, and when you load it the radius will increase because z is going to become less. ठीक है सर? Any other doubt? Okay. तो आगे चलते हैं सर अभी कॉइल स्प्रिंग का डिजाइन के लिए। जस्ट वेट। Sir, for automobile engineering, please understand that the most of the time the design is based on the trial and error method rather than any formula based. Even if you design this spring by using these kinds of formulae, but let me tell you that the final design will not be exactly same as whatever the dimensions you arrive. It will be based on the fatigue testing of the spring, and you need to modify the design because the reason is you got to have the unaccounted load on the spring. That means you cannot predict the loads exactly which are coming on the spring. So you have to design the spring with certain factor of safety. So design of coil spring. In machine tool, you can design these springs and everything with the you can say some load by using the formula, whereas in automobile it can't happen because you do not know the various types of loading conditions, and there are certain other aspect, that means the how much is the fatigue damage which is getting accumulated into the component. So that is very complicated design, and understanding the dynamics of the forces involved, that is another aspect, because no parameter remains constant in the automobile. That means if you vary the speed, the acceleration will vary, then the quality of the road is different, then sometimes the vehicle will move with the full load, sometimes with partial load, then there are certain fatigue or static loads which are coming, then the road irregularities is the most dangerous thing. So you never know, you don't attempt to get the exact loading of the vehicle. Okay, because once you drive on one particular road, the load pattern will be different, and if you change the road, again the load pattern will be different. So be careful when if somebody is claiming that this is the exact formula by which you can get the actual dimensions of the system, then please be careful that such kind of thing doesn't exist in automobile. At least I have seen or I have learned in my career कि ऑटोमोबाइल में अगर आप ऐसे ही बात करते हो कि ये जो है ये परफेक्ट फॉर्मूला है आप इससे डिराइव कर लो तो दैट मीन्स दैट पर्टिकुलर फेलो इज फूलिंग यू सो प्लीज बी केयरफुल so this is going to be the spring coil spring see the issue with the automobile is that you can't have the scope for over designing it. If you over design it, the cost is going to increase tremendously. Okay, and unnecessarily you will be having trouble in meeting the emission norms because the fuel consumption will increase. The moment your fuel consumption is increased, the problem with the emission testing will happen. So, sir, never try to attempt to have the perfect design. So, if you take the cross section of the wire, so this is the cross section of the wire, then cross section will be something like this, which is having the diameter as, let us say, small d. Okay, and this is the diameter of the coil spring, which is denoted as capital D. So, I will write down P is the axial load on the spring. Axial load on spring. Small d is the dia of coil spring wire. Then d is the mean coil diameter. Mean coil diameter. N is equals to number of active coil. Fs is allowable shear stress. Allowable shear stress of spring material. G is equal to modulus of rigidity. Modulus of rigidity of spring material, that is almost equal to, this is just I am giving you the figure, 7357 into 10 raised to power 6 Pascal. So this is not that this is a compulsory value, but this is the general range. Delta is deflection of spring. So deflection of spring. So here we can say that the delta is given as delta is equal to pi capital D square N Fs divided by G into small d. This is also equal to 8 small n P capital D cube divided by G d raised to power 4. Second equation for the allowable shear stress Fs is equal to G d delta. That means how much deflection you want. Pi d square n. This is also equal to 8 P capital D divided by pi small d. Okay. Now energy is stored in spring. So energy stored in spring. This is given as P delta by 2. And after that, the volume of spring, this is given as pi square d square capital D n divided by, so this is the volume, then energy per unit volume. Should not get confused with capital E. So P delta by 2 divided by V. So this comes out to be Fs square divided by 4 capital G joule per meter cube. So these are the general formulas. These are available in the book, even it is available in the design data book, but we are going to specifically use this formula for calculation. Ours is not going to be the design actually. We need to know what is the maximum deflection, what is the maximum allowable shear stress. So these are the formulas which have to be used for the designing of the coil spring, which is used in the suspension system. So now how to calculate the load on the spring. So load calculation for spring design. So let it be the coil spring or let it be the leaf spring. How to calculate this? This is the important thing which we need to understand. Most of the student or even designer, they make mistake by estimating the wrong value of the load which is coming on to the spring. See, we know that कि चलो सर ये मान लो कि ये आपका रोड सरफेस है, पहले हॉरिजॉन्टल रोड सरफेस की बात करते हैं। तो सर ये this is the vehicle. You know that this is going to be the location of the CG. So CG is center of gravity. Now from here weight W will act. Okay. Now you know that this distance between the two wheels of the vehicle, you term this distance as L, that is the wheelbase. Okay. So wheelbase of the vehicle. Now there will be two reactions which will be acting here. So one is the RF, that is the reaction of front wheel. The other one is the reaction which is acting as reaction of rear wheels. Okay. Now for equilibrium, please understand, for equilibrium, your W has to be equal to RF plus RR. Okay, let us say that this is your equation number 1. Now, to get RF, okay, so take moment about the center of rear wheel. So if you take the center, let us say that if you take the moment about the rear, so this distance, let us say you take this as x. Okay, so w into x is equal to rf into l. So rf comes out to be w into x by l. So this is equation 2. So from 1 and 2 you can get rr is equals to w minus r. So this is how you can get this and this. This is the equation. But this is not, this will not end the matter. So this for spring design, for front, let us say if you are designing it for front, then P comes out to be RF front reaction divided by 2, and for rear P comes out to be RR divided by 2, because these are shared by two springs if it is the four-wheel vehicle. So please keep this thing in mind. This is the important thing for designing of the spring. Please do not take the only RR value or RF value for designing of the spring. So spring load has to be calculated. Then with this P, you can go on increasing the value of the P by adding certain factors, particularly dynamic load के लिए, unaccounted load के लिए. So that all can be considered in the form of the factor of safety. So is this clear, sir? Anybody is having any doubt? Sir, please say yes or no. If you have a doubt, please ask. If you do not have a doubt, then I'll stop here. I have the important announcement to make here. So please don't leave. सर किसी को कुछ डाउट है क्या? जस्ट पूछिए. अगर डाउट नहीं है तो सर मैं फिर आपको बता देता हूं कि मुझे क्या कहना है. प्लीज वेट सर. हाँ, तो सर किसी को कुछ डाउट है क्या? अगर डाउट है तो पूछिए. सर रिप्लाई कीजिए, नहीं तो ये तो वन वे ट्रैफिक हो गया सर. चलो, हाँ ठीक है. एक इंपॉर्टेंट बात सर, मैंने आपको एमसीक्यू मल्टीपल चॉइस क्वेश्चन वाला जो टेस्ट दिया था, उसमें मैंने बोला था आपको कि मैं निगेटिव मार्किंग करूंगा. बट लुकिंग एट योर स्कोर आई ड्रॉप दैट आइडिया. अगर आप मैं निगेटिव मार्किंग कर देता तो उसमें आपका स्कोर काफी नीचे चला जाता है. ठीक है, तो मैंने वो आपके एडवांटेज के लिए वो फिलहाल मैंने विदाउट निगेटिव मार्किंग आपको मैंने ये आपका स्कोर भेजा है. तो सर थोड़ी सी ऐसी कृपा करना, नेक्स्ट टाइम थोड़ा सा पढ़ना और प्रॉपरली आंसर करना सर. ठीक है, तो बाकी कुछ प्रॉब्लम नहीं है. तो जितना भी हो सकता है मैं आपके एडवांटेज के लिए ये